In this video, we'll look at what the quotient rule for derivatives is and prove its correctness. The quotient rule states that given that a function h of x is equal to the quotient of differentiable functions f of x and g of x is not equal to 0 for the value of x of interest, then the derivative h prime of x is equal to g of x times f prime of x minus f of x times g prime of x over g of x squared. To prove this, let's start by taking the derivative of f of x over g of x using the definition of the derivative. Note that the variable h in the limit expression is of course different from the function h. If we combine the difference of fractions in the numerator and then bring in the h from the denominator of the outer fraction into the denominator of the numerator, we get g of x times f of x plus h minus f of x times g of x plus h over h times g of x times g of x plus h. We know that we want to separate the f's from the g's in the numerator, so what we can do is add and subtract the term f of x times g of x, since adding and subtracting the same quantity leaves the expression unchanged. Now the terms linked by the green line can be grouped together, and the terms linked by the red line can be grouped together. If we group the green and red terms next to each other, flip the order of the red terms, and parenthesize the red group, knowing that subtracting minus f of x times g of x is the same as adding f of x times g of x, we get the expression on the bottom. We can factor out 1 over g of x times g of x plus h as shown here. And now we can use the product law of limits, that the limit of a product is the product of the limits, to rewrite this as the limit as h approaches 0 of 1 over g of x times g of x plus h times the limit as h approaches 0 of the other fraction. As h approaches 0, g of x plus h approaches g of x, so the limit expression on the left becomes 1 over g of x squared. Now for the fraction on the right, we can separate this fraction into the difference of two fractions as shown in this expression. Now we can use the sums and differences law of limits to turn this limit of a difference into the difference of two limits as shown here. Now we can factor g of x out of the numerator of the left fraction and f of x out of the numerator of the right fraction, and write the current expression as so. Now we can use the product law of limits, which states that the limit of a product is the product of the limits, and write the expression as so. Notice that the limit as h approaches 0 of g of x is just g of x, and the limit as h approaches 0 of f of x is just f of x, as neither of these expressions have h in them. Also notice that the limit as h approaches 0 of f of x plus h minus f of x over h is the definition of the derivative of f of x, and likewise for g of x. So we have 1 over g of x squared times g of x times f prime of x minus f of x times g prime of x. If we factor back in the 1 over g of x squared, we get the expression we set out to prove.